And now we are going to move forward to the last presentation of this webinar, which address what's coming next and the future of paper-based flexible packaging. This presentation will be given by David Guérin, who is manager of the Functional Surfaces and Products team at CTP. David holds a PhD in material science and process engineering and has more than 20 years of experience in paper surface treatments and in the development of cellulosic-based materials for specialty and packaging markets. He has published more than 20 papers and made about 60 communications in international conferences, and is also the inventor of 12 patents. So David, the floor is yours.
Okay, thank you, Caroline. So, I'm appearing here under CTP ceiling because we are all together in a meeting room at the CTP, but it's really me who is presenting. And during this presentation, I will review some main drivers and challenges for the flexible packaging market, and I will try to highlight the main achievement of Sherpack about MFC wet lamination, bio-based emulsion, grid printing, and try to point out some opportunities or threats for this development, and to point where we are going in these three developments for the next years. So the European market of flexible packaging is a still growing market with from 4 to 5% annual growth according to several consultant firms. And there are some drivers linked either to general policies, but also to consumer, to brand owners, and it can be underlined, for example, by the appearance of e-commerce, which is really something gaining a high share of market, but also for people having new expectation, and it's often referred as millennials who have different wishes than past generations. So, and regarding the products, there are still some development to make lighter product. And if we look at the market share of flexible packaging, it's gaining every year some market shares over rigid packaging. So I would say that flexible packaging market in Europe has a bright future from now, but it's raising some concern about the environmental impact on recycling of this material in Europe. Next slide. And if we try to define the ID card of tomorrow's material, you need a high barrier and a high strength. And their barrier is really linked to shelf life. So, of course, some brand owners are ready to rediscuss the shelf life of some of their products, but the consumer safety must not be impaired by a redesign of the barrier performance. So, there, it's a difficult equilibrium to try to find between the food, its conservation over time, and consumer safety versus product performance. And generally in Europe, most of the brands are global, so it means that even if we are not suffering from very high temperature and high moisture at the same time, such as in tropical countries, we need our packaging material to be with the same performance, whatever the temperature and humidity, because global brands are marketing their product in every corner of the world, despite the fact that they are manufactured in Europe or no. And so also, when you would like to develop a new material, it has to comply with existing converting and conditioning machine. Even if some modifications are possible, it's not possible to change at once the whole park of machine converting the material into packaging. And for sure, the cost is still a key issue in this market. And in Europe, there is a rising interest in development of recyclable products that are truly recycled with well-established collecting and recycling stream and with a high recycling rate. So it's really a focus that is set in Europe today. Next slide. And so if we turn to paper-based flexible packaging that are one option, the main challenges are barrier performance, and I underline both oxygen, because we are obviously not yet close to a plastic solution today. But water vapor barrier is even more important, because it's where most of the development have to be done in the coming years. The strength to weight of the material is also important. In the past LCA, we compared 60, 70, 80 grams per square meter paper with a 40 grams per square meter plastic packaging. So we still have some margin on improvement on the strength of the material versus its basis weight. The material must be with a good runnability on existing conditioning line, to get some stretchability for puncture resistance and shock resistance. If possible, some transparency and a very good heat sealing with a high seal strength. And for sure, it must be cost-wise as well. So all these developments have to be done on paper-based packaging material. And Sherpack addresses some of these developments, but not all of them. It was not possible to include all these developments in a single project. Next slide. So Sherpack brings some very adequate solution. For example, the MFC wet lamination targets the development of the oxygen and grease barrier performance with a material that would be made only of cellulose, which means perfectly recyclable and biodegradable by design. The bio-based emulsion of PLA was targeting both the heat sealing performance and the water vapor barrier performance of the material. And the grid printing was targeting to make lighter and stronger material. So these three developments are really in line what is needed to make the future paper-based flexible packaging material. But where we are today at the end of the Sherpack project and what's next regarding this single development. Next. So regarding the MFC wet lamination, during Fleur's presentation, you saw that the process is at technology readiness level 5 today. So it means a small pilot machine is operating, and there is a need to get a better and in-depth, better understanding and in-depth analysis of the 3 steps of the process, which are MFC filtration, wet MFC film replication, and material drying in the end. And there are for sure some product development needs, such as curl management, post-treatment, what solution to bring the water and vapor barrier on this material, how can it be converted from a real to a real packaging, what gluing and sealing solution, what is the converting ability of the material. And last but not least, the economics behind must be refined to get the good positioning of this product versus market need. And when all of this will be done, we need to develop the process at higher technology readiness level. So, but behind the development of this technology, it is also linked to the development of the MFC production capacity. Next slide, Caroline. So if you look at some market prospect for the production of MFC, so I pick up here a slide from Future Market. In 2018, it was estimated that the MFC worldwide production was 10,000 tons. And if you look at what we can do with the Sherpack concept with 10,000 tons of MFC, it means that we can manufacture 52,000 tons of packaging, according to the proof of concept 1 of Sherpack. This figure has to be set in front of, for example, the EU wrapping paper production is today almost 800,000 tons. So you clearly understand that the MFC is not available yet in such an amount to cover the foreseen need for the packaging market. So we need to drive the development of the MFC production facilities as well, and try to incent players in this field to develop even larger capacities than the one existing today. Next slide. And at the CTP, we are developing the MFC wet lamination. And this technology was invented at the CTP in partnership with CNRS. And we are, since the invention in 2015, raised public funds for several projects. So Sherpack is one of them. And today there is another BBI project named Celuiz, which under the understanding of this small pilot machine at TRL5 scale. And this project will bring all the elements to develop a demo machine. So the next step will be a demonstration at large scale. And for this, we need a combination of private and public funding to minimize the financial risk around a demo machine. So that's things which are going on at the CTP in this field. Next slide. So regarding the bio-based emulsion, today the technology is at TRL5 as well. So it means that ESOF has developed some capability to produce samples of this emulsion. And there is a need to upscale for sure the production of this material. But also what was pointed out in the project is that we do not get in the end the promised performance by the use of PLA. And it is mainly linked to the fact that there is a needed step after coating and drying to create a film out of an emulsion. And this can be called as annealing, how you turn from spherical material into a coherent film. And we know that we still have some research to do on this annealing step to get the best performance from the emulsion in itself. And there is really a very good opportunity there already, because it was shown that this PLA emulsion can bring heat sealability to the paper and water resistance, which is already very good performances for some market. And if you look at the market, there is only one competing product on the market, a PLA emulsion supplied by a Japanese company, but this PLA emulsion has no food contact agreement. So if you are looking for a bio-based and biodegradable heat sealing material to be used in food contact packaging, there is no possibility today. So this development really opens this. But there are also some threats, and I would like to point out one, which is about policy and regulation. So next slide, Caroline. Last year, in Europe, a directive was adopted on June. It is known as the Single-Use Plastic Product Directive. And if you look at this directive, which targets several packaging, and here, for example, I underline twisting paper on small crisp packets that could be potential product made with Sherpack development. It is specifically written in this directive that you can't use any plastic layer in your packaging, even if the plastic layer is bio-based and biodegradable in the end. So so this directive can restrain the potential market for the use of PLA emulsion. So I won't say that there is not a bright future for PLA emulsion, but we need to know that on some specific market, it's not a solution that can be used today. So it helps the scientist and engineer to develop product in the right direction, to be aware of these policies. So next slide, Caroline. The third major innovation of Sherpack is this grid printing. And today the technology is at a lower scale. I would mean technology readiness 3 to 4. And there is a need to validate the concept at larger scale. And we saw several questions on the chat mentioning how we can use this interesting process in the frame of making a packaging. What is the best strategy to use this? How we can combine this with converting, with printing, and so on. So obviously there are still plenty of things to do. And one question could be, can we find other function of this than stiffness and other applications than flexible packaging? And this approach has been patented by Cargill and the CTP, and there are discussion on the best way to move forward there. So next slide. But I would like to point out that if we calculate the apparent density of material thanks to this grid printing, for example, the Sherpack proof of concept 2, which uses this grid, the apparent density due to this grid printing is only 0.8. It has to be compared to all the other densities, apparent density mentioned here. So this grid printing is really a good way to make stiff and strong material with the best use of the raw material in themselves. So it's really something promising, and there is still some work to do on upscaling and finding the right production scheme for using this technology. Next slide, please. So as a conclusion, I would like to point out that Sherpack has brought interesting achievement in the field of barrier performance. The barrier to oxygen were excellent and the water vapor barrier were not as good as expected, but it is explained by these annealing steps that need further development. The strength to weight ratio, there are some really big leap forward thanks to this grid printing. And the heat sealing is also something of high interest coming out from the Sherpack project. So compared to the need of development for making paper material using its biggest share in the flexible packaging market, Sherpack brought very interesting results in this field. Next slide. And Sherpack really deal with what matters for paper-based flexible packaging and how we can move forward. Next slide. In fact, when you would like to develop a new packaging material, there are almost 70 to 100 questions to answer, and that's all the performance which are listed on this slide, so I won't list them all. But in green was what of peculiar interest and focus in Sherpack. But for sure, there is a need to check all the other performances mentioned on this slide. So there is still some product check and product development to do in the field of this new packaging material. Next slide, Caroline. And lastly, I would like to say that Sherpack was possible thanks to the BBI funding, which associate public and private funds. And since we were at low technology readiness level, this public funding was really needed to take the risk on the technology. And the next step is upscaling. And when upscaling, the amount or the budget needed for upscaling are even bigger. And here again, there is a need to have a good combination of private and public funding. So we are, all the Sherpack partners are really motivated in the idea to continue the development. And we are looking both for public funded calls to be able to do the upscaling and also a private partnership to move forward as fast as possible, because here the time is highly linked to the financial capacities and the budget we are able to raise to move forward. So I would like to thank you for your attention, and if you have any questions, they are welcome.